The standard scientific consensus describes the foundation of our universe as a chaotic environment. We are taught that atoms are unpredictable clouds of electrons and that quantum states function as random fields of probability. This model presents a paradox. If the base layer is random, it shouldn't spontaneously construct the perfectly stable, highly organized structures we see in the macroscopic world. The reliable stability of the objects around us suggests there is a non-random structural rulebook operating beneath that apparent microscopic chaos. An alternative theory proposes that underneath the microscopic blur lies a perfectly balanced three-dimensional geometric grid that scales infinitely. This spatial scaffolding provides the physical logic for the universe, dictating the strength of chemical bonds and the specific behavior of quantum fluids. Identifying this exact geometry turns our understanding of the universe from a system governed by chance into one governed by precise structural engineering. Architect Buckminster Fuller dedicated his work to finding a master geometric form that could represent the mathematical zero reference for our three-dimensional reality. He called this the vector equilibrium, the absolute zero point of space. Here, every vector radiating from the center and circumference has the exact same length. Because these are identical, outward explosive and inward gravitational forces perfectly cancel each other out. This equilibrium is achieved in physical space through a 12-around-1 geometry, where 12 identical spheres pack perfectly around a single central nucleus. When you link these equilibrium units in every direction, you create the isotropic vector matrix, the invisible structural canvas that provides the framework for space itself. This infinite matrix is the unmanifested blueprint. It remains static until a catalyst of movement begins to construct physical matter within the grid. This catalyst is the jitterbug motion. When a vortex or spin is introduced, it creates tension that pulls the vertices of the vector equilibrium toward the center, moving the system out of its static zero phase. This resulting structural tension generates physical matter, following the same tensegrity principles used to build stable, lightweight architectural towers. In this model, electrons travel along 25 precise great circles defined by the underlying vector equilibrium geometry, rather than moving through a hazy cloud. Molecules bond by interlocking these specific geometric pathways. In a carbon-based methane molecule, these paths form two interlocking tetrahedra that provide the rigid structural bracing for the entire system. These atomic structures are held together by architectural tensegrity, where the nucleus acts as the glue for a system of geometric tensile forces. Transitioning to a larger scale, as we scale up from the atom to macroscopic quantum states, the rigid lines of the scaffolding begin to behave collectively like a superfluid. The fundamental topological shape that stabilizes these energetic fluids is the torus. This toroidal geometry creates topologically protected energy gaps. In the fractional quantum Hall effect, this topology prevents the fluid from losing energy to its environment, granting it incredible stability. To maintain this stability across different scales, the matrix follows a specific mathematical ratio, r² minus r minus 1 equals 0. The positive root of this equation, the golden ratio, acts as the self-consistent scaling factor for the entire system. The golden ratio ensures that as the fractal matrix grows from atoms to macrofluids, the dimensional layers remain synchronized without collapsing. The physical world is a dynamically scaling geometric scaffolding, stretching from the zero point of space to the largest structures in physics. Mastering this structural knowledge, from the tensegrity of an atom to the topology of a quantum fluid, allows us to engineer artificial molecules and stabilize quantum states with high precision. By replacing the ambiguous electron cloud with these rigid geometric bracings, we can align atomic pathways to eliminate the chaotic scattering that causes electrical resistance. This provides a direct engineering path to room temperature superconductors and stable quantum computers. Cracking the universe's exact geometric rulebook means we stop observing the outcomes of physical laws and start designing the structures that define them.